All right, starting off with a partner practice. Again, you guys can just, I'm actually okay if you probably skipped it, but if you want to get a practice just for another sequence, writing it out, pause the video and then I'll go through it and give you the answers here. All right, so if you got it right, so first term, write the first six terms. The first term is almost like piecewise. If it's odd, it's 1 over n. So first term will be 1 over 1, which is just 1. And then if it's even, it's just the number n itself. So like second term is 2, the fourth term is 4, the sixth term is 6, because those are your even ones. And then the odd ones are just 1 over the number. So this would be 1/3 and 1/5. But all right, the video is really going to focus on two different things. So what you've done before is basically I've given you guys the nth term and the definition for the nth term, or the equation for the nth term, and you've written out the sequence with some number of terms. Now we're going to do the opposite, where I'm going to give you the terms, and then you have to write out the equation for the nth term. Right, so it kind of like, look at these for a second so that you can kind of like figure them out on your own and then resume the video and I'll kind of give you the answers. Number 4 is very, very difficult. To be surprised if anybody gets it, but I'm sure somebody can think of it. But the first 3, hopefully you can kind of get, right? So pause the video, and then when you feel like you've given each one an honest chance, go ahead and, resume it. All right, so for this first one, right, we're talking about the nth term. So I'm going to write a sub n equals something. So if you look at the numbers, you got 1, 4, 9, 16, and 25. So it's like, how are all these numbers? How can I write them, right? But if you notice them, they're all perfect squares, right? So these are all squares. Like, so first term, if I did 1 squared, I would get 1. Second term, if I did 2 squared, I would get 2. Third term, if I did 3 squared, I get 9. 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25. So this is just going to be n squared, right? And that's it, right? So like and you can test it. If you plug in the term number, do you get the actual value that you have written out? And you do. The second one, I think if I took away the first one, it would probably be a little easier. You can see it's like e to the power of 2 over 2 for the second term, e to the power of 3 over 3 for the third term, e to the power of 4 over 4 for the fourth term. So if we're going to say the nth term, it's usually just going to be e to the power of n over n, right? And so those numbers like 2 and 3 and 4, you see them written twice. So you're going to write n twice. But the one that doesn't look like it would match would be this one. But if you think about it, so for first term, e to the power of 1 over 1, well, that does simplify to just e. So they usually give you the simplified version in the pattern. So try and follow along with the other ones, and it probably makes more sense. But good if you got it. The third one is kind of like that. We see that same thing where it goes like positive, negative, positive, negative, positive. So I'm going to write it right above it. But that was that same little device you saw earlier where it was the -1 to the n minus 1. That little thing is going to get you to positive, negative, positive, negative. That's what it did before. So like that kind of takes care of the negative sign. So now you're just looking at the actual numbers themselves. So it's like 1, second term is 1 over 2, third term is 1 over 3, fourth term is 1 over 4, fifth term is 1 over 5. So basically this is just going to be times 1 over n, right? So the term numbers in the denominator. And again, think of the first one as 1 divided by 1. So it does work for that one. It just simplifies to 1. And then the last one looks like it might be the easiest. Well, like it's just odd numbers. That seems pretty easy. It's just sometimes hard to write out odd numbers or even numbers. If it was even numbers, it's a little easier, right? If we had 2, 4, 6, 8, dot, 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 right? That's just going to be like each one gets multiplied, or each one doubles. So if we just did 2n, that would mean, right, if I plugged in 1, first term would be 2. If I plugged in 2, second term would be 4. If I plugged in 3, third term would be 6. So that's basically even numbers, 2, 4, 6, 8, 10, all that stuff. But if I have odd numbers starting with 1, I still do 2n because that's what's going to get it to go up by 2 every time. But if I subtract 1, now when I plug in 1, I'm going to get 1. And when I plug in 2 for second term, I get 3. When I plug in 3 for third term, I get 5. When I plug in 4 for fourth term, I get 7. So that -1 is kicking it down 1 from the even numbers, which gets you to odd numbers. If anybody got that, that's pretty impressive. All right, and last thing, recursive sequences. It sounds difficult. It's actually pretty easy. It's easier than what we've been doing, actually. But basically, recursive sequence just means that you have to be given usually the first term, sometimes more, but like usually you're just given the first term and then you work off of that to find the next terms. That's all that it means, right? So you can tell that this practice one is recursive because you can see here, it gives you the first term. It says S sub 1. That just means first term. Here they're using the letter S. Again, letters will change. So it says S sub 1 equals 1. So it just means the first term is equal to 1. And then it says write the first 5 terms. Well, I know that the first term is 1 because it told me that. So that's not rocket science. But then it says the nth term is going to be 4 times this S sub n minus 1. And that's the big thing with recursive. S sub n minus 1, don't think of it as like plugging a number in for n, although it does work, but don't think of it that way. That is what we know as what's called the previous term, right? That's how I want you to think of it. So S sub n minus 1 is previous term. So basically, it's saying that the nth term is going to be 4 times whatever term came before it, right? So if I know that the first number is 1, I needed to know the first term. Otherwise, I would be like totally screwed here, right? So I know that the first term is 1. So if I want to find the second term, right, it is simply 4 times the previous term. So if the previous term is 1, the second term is just going to be 4 times 1, which is 4, right? Then if I want to find the third term, again, it's 4 times the previous term, and the previous term is 4. So 4 times 4 is 16. Right, and then we can just keep going on. The fourth term would be 4 times the previous term. So 4 times 16, which is 64. And then the fifth term would be 4 times the previous term. 4 times 64 is 256. And that's all that it means. It's actually not too bad. So what I want you guys to do is pause the video one last time. You're going to knock out these 2 questions, and then you will be done. I'll skip the summarizer for you so you can go right to the homework. All right, so if you pause the video and given these ones a shot, great. Basically, this is saying the first term is 7, so write out the first 5 terms. The first one's going to be 7. And then it just says the nth term is going to be the previous term plus 3. So the second term would be the previous term plus 3, which would be 10. And then the third term would be the previous term plus 3, so that's going to be 13. Previous term plus 3 is 16. Previous term plus 3 is 19. And that's it. And then this one, I want you to write the recursive rule. So again, if it's a recursive rule, we need to give them the first term. So we would say a sub 1 is whatever the first term is, which is 3 in this case. And then how do I get from 3 to the next term to the next term? And you can see they're all just doubled. Right? If I doubled 3, I get to 6. I double 6, I get to 12. I double 12, I get to 24. So then the nth term would just be the previous term doubled. So I'm just going to write doubled as 2 times something. That's the same thing as doubled. So if I do 2 times the previous term, and I know that previous term is that a sub n minus 1 notation, then I'm good. If you put a sub n minus 1 times 2, it doesn't matter. I put the 2 first. It doesn't matter if you put it second. Somebody last class said a times n minus, or a to the sub n minus 1 plus a sub n minus 1. Sure, right? Those are all good. So good job today, guys. You're done.